Now let's introduce the insulating oil dielectric loss tester. Pulling the handle leads to our workbench. This is the touchscreen. This is the printer. Open the top cover of the device. This is the oil cup holder. These two are the temperature and current signal ports, respectively. The side of the device features a power socket, switch, and grounding port, and also has an optional RS-to-3 port. The insulating oil dielectric loss tester must be connected to a grounding wire. Then connect the temperature and current signal lines. Note the groove on the temperature signal cable. Align with the temperature signal cable port. Insert and tighten. Connect the current signal line to the corresponding port and then tighten it. These are our test oil cups, specifically the inner electrode and outer electrode cups. When removing the test oil cup, touch the outer rubber ring and try not to touch the cup wall. Insert the temperature signal cable to the bottom and tighten the current signal cable. After installation, close the top cover and open the workbench. Turn on the power. After powering on, the first option is the test conditions. Clicking on this allows you to configure settings such as AC out DC voltage and temperature. The second is the empty cup test, which can detect whether the oil cup is clean. The third is automated testing. The fourth is data query. The last other interface does not require customer operation. Before conducting the formal oil sample test, we will first perform an empty cup test to check the condition of the oil cup. Here you can select the dielectric loss factor, relative permittivity, and volume resistivity. Choose according to your experimental needs. After setting it up, click to enter. The equipment has begun testing. This is the heating phase. The temperature rises from room temperature to the 90 degrees Celsius we set. Do not open the top cover during testing. After the temperature reached 90 degrees Celsius, the equipment began AC testing. AC voltage increased to 2000 volts. Once the AC voltage reaches 2000 volts, the device begins a 1-minute countdown. After the 1-minute countdown ends, the DC test will begin. After the voltage is raised to 500 volts, the equipment stabilizes for 1 minute. After 1 minute of timing, the device displays the empty cup test results and prints them automatically. If the dielectric loss value in the empty cup test is less than 0.00010, it indicates that the oil cup is not faulty and oil sample testing can begin. This is the printed test result. After the empty cup test, wait for the oil cup to cool to room temperature before testing the oil sample. Next, we will conduct an oil sample test. Open the top cover, remove the temperature and current signal wires, and take out the oil cup. Remove the inner point cup and place it on the cup holder. First, rinse the electrode cup with our test oil sample. You can rinse it several times. Pour 35 milliliters of oil sample into a measuring cup. Place the oil sample into the outer electrode cup. Then remove the inner electrode cup and rinse it back and forth. The oil cup should be rinsed at least 3 times. After cleaning, pour the oil sample into a waste bottle. Take another 35 milliliters oil sample for testing. Pour the oil sample into an oil cup. Install the internal electrode cup and place the oil cup into the working tank. Install the temperature and current signal lines. Close the top cover. Click Auto Measurement. Select the dielectric loss factor, relative permittivity, and volume resistivity according to experimental requirements. Then press Enter. The equipment starts heating. After the equipment heats up to 90 degrees Celsius, it begins AC testing. After boosting the voltage to 200 V, a 1-minute countdown begins. Then the device enters DC testing. After the voltage is increased to 500 volts, the equipment enters a 1-minute rest period. The test is completed, and the equipment displays the results and prints them automatically.